Right, here we go. Equivalent fractions. Um, so, here's the starter for you. Mitch has saved some money from working hard and he gives away half to charity because he's a top lad. That's what top lads do. And he now has £40,000. So he's been working very hard and he's got 40 grand. Well, no, he's given half of it to charity. And what he's got left is £40,000. So how much did Mitch start with? You might be able to tell me that straight away. There's how much he's got left, and that is half of what he started off with. So how much did he have in the beginning? That's a bit easier now. That's how bar models make things easier. Anyway, right, equivalent fractions. So when I said equivalent fractions today, Malia was like this. Exactly like that. And then who else? When I said equivalent fractions, Tyler went like this. That was definitely Tyler. But it's actually not that difficult, believe it or not. So you all know about things that are equivalent. You might not use this word very often, but it's just things of equal value, the same amount or the same meaning as something. So here's one that you know. How much is there? 5 squids. And it's equivalent to a £5 note. Same thing. They're both equal value. Let's have another one. 3 plus 3 equals, you're probably all shouting out 6, and that is right, but it's also equal to that, 5 plus 1. That's all, it's all equivalent, it's the same, equal. And 1,000 meters is the same as 1 kilometer, is equivalent to 1 kilometer. So they're all things that you've come across before, that you know, and it's just the same with fractions. Some of them are, they look different, but it's exactly the same amount. So it is a little practical step for you today. You're going to get 2 bits of paper. So you have to get some little bits of paper. I'd recommend just getting a piece of scrap paper, like some of the junk that comes through the letterbox. Cut up 2 strips, but the key thing is they need to be equal sizes. So they need to be equal strips of paper. So like they look a bit like this. That is your first step. Second step is fold one of the strips in half. And then the other second step is fold the other strip into quarters. So basically what you do is you fold it in half and then fold it in half again. And you'll hopefully be left with 2 pieces of paper that look a little bit like that. And hopefully, how many quarters, you'll be able to answer this question yourself, how many quarters are the same as 1 half? So let's look. So here's the one that was split into quarters. We know that because it's split into 4 equal parts. And we've got 1 quarter, 2 quarters, 3 quarters, 4 quarters, make the whole. Oh, there's a half first. So it's in 2 equal parts, it's half. And there's 1 quarter, 2 quarter. That is, they are equivalent fractions. So 2 quarters is equivalent to 1 half. That's simple. And you can use that piece of paper to work out loads of different fractions. If you were to extend this and you were to take the paper that's folded in 2 halves, so I'd recommend taking this piece, fold it in half again to make quarters, and then fold that again to make eighths. Then what have you got? Then you've got something that might look like that. So you could have 1 quarter and 2 eighths. You could identify that. You could make it so you've got 2 quarters, and how many eighths would you have? If you've got 2 quarters, you'd have 1, 2, 3, 4 eighths would be equivalent to that, and it would also be equivalent to a half as well. 2 quarters is equivalent to half. We just established that. Right, I will show you some more examples. But you can use those pieces of paper throughout the lesson to help you with any of these things that we do today, as long as they're folded into the right equal amounts. So here's an example of a bar model. We've got the 1/3 here, 1/3. There's 1/3, it's split into thirds, 3 equal parts. And yes, I've got the colour. There is one of them coloured in. So that is equivalent to how many? 1, 2, 3, 4, 5, 6. how many sixths? The denominator is 6. We know it's 6 equal parts. That is equal to 2 sixths. Boom. And here's a practice for you. Practice with that one. See if you get that right. Pause the video. If not, 2 tenths. So I'm looking at my tenths here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal parts. I'm going to colour in 2 of them. And that we can see is equal to 1/5. Excellent, well done you. And oh, here we go. We've got 2 more things to practice here. Hopefully you've paused it and you've had a go thinking about it yourself. I will explain. You've got 2/3. It's getting tricky now because these are non-unit fractions now. I'm sure you all knew that. This one's split into thirds, 1, 2, 3 equal parts. We're going to colour in 2 of them. That devastates me that they're ever so slightly off the original thing, but never mind. And that is equivalent to 1, 2, 3, 4 sixths. And this one, I just shouting this one out. 1, 2, 3, 3/4 is equivalent to 1, 2, 3, 4, 5, 6, 8. They are equivalent, they have equal value. There you go. So if you had 2 chocolate bars and you cut them, one of them into quarters, and you gave someone 3/4, that would be exactly the same as if you had a chocolate bar and you cut it into 8 and you gave them 6/8. Right, here's something that's going to blow your minds even further, but actually this will hopefully be used to help later. So here's a whole. There's one thing, it's a whole. And then in 2 parts, 2 equal parts is a half. And then, oh, what was that about there? A bit funny there. Got thirds. 1, 2, 3, 4/4. Fifths, sixths, sevenths, eighths, 9, 10, 11, and 12ths, all the way down to 12. So the width of it in this bar model that's the whole. And then down here, got it split into 11ths and 12ths and all sorts. And you can see from here, if you go on to the next slide, a half. So we can colour in a half here. And if we look down to see, we can't split that, that's not going to go in equivalent because it's in thirds. But hang on a second, we've got 2/4 here, which look like they're equivalent to a half. And then if we go down, no, we can't do fifths. Hang on a second. 1, 2, 3 sixths is equivalent to a half and is also equivalent to 2/4. Well, this isn't working out for me. But this one is, hello, we have got 4/8. So 4/8 is equivalent to 2/4. 4/8 is equivalent to 1/2. 4/8 is equivalent to 3 sixths. And hang about, what's this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5/10. That's also equivalent to a half, and 4/8, and 3 sixths, and 2/4. And then finally, you might have guessed it, but we can't see it. I've got to learn to get rid of that thing. 6/12 is equivalent to a half, and all those other ones exactly the same. Right. What about this one then? This is just showing it in 1/3 and 2 sixths and 3 ninths and 4/12. That's another way of showing they're all equivalent to 1/3. Right, how about this one? This is some mind-blowing stuff. Which is the odd one out? Have a pause of the video and see if you can work it out. I'm going to now talk it through it. So we've got a half to start off with. It's 2 parts. And then this one, is this equivalent? Well, yeah, it is, because we've got 2/4. We know that's equivalent. And this one can't be, can it? This one, hang on a second. It's 1, 2, 3, 4, 5, 6. And there are 3 sixths coloured in. So actually it is. That is equivalent to 1/2. Because 3 sixths is the same as 1/2. We've got here, actually we can see only half of the colours, the things have been coloured in. So it's 4/8 there. And then there's not one here. And then we've got one here. We've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 left over. So that is 6/11. 6/11. So I think we found our culprit. Let's just double check. That bottom one is 6/12. So there is our culprit. Kapow. I'm sure you've got that well done as you got it. Right now, it's 10 minutes of chatting. We are going to go into the independent challenge and see if you can work out some of these. So the independent challenge, you can start off with green. I've got the bar model here for you. 2/3 is equivalent to how many sixths? So 2/3 is equivalent to how many sixths? They're the sixths, there's the thirds. I've coloured that one in for you, nice and straightforward. This one steps up a little bit more. We've got 2/4. So here's the quarter split. The denominator is 4. So it's 1, 2, 3, 4 equal parts. It's split into how many eighths? So here's your eighths. How many eighths are equivalent to 2/4? Now, you can use that bar model. I've not coloured it in for you. So you have to start thinking, using your noggin. Then we can take it a notch up from that if you've gotten okay with those things, and you can fill in the missing fraction, in this case numerator, but it's not always a numerator. Check these guys out down here. Denominator's missing down here. This one, if you are stuck, I would recommend using the fraction chart on slide 12. So 2/5 is the same as something tenths. So what I'd recommend to do, bear with me a sec. I don't know why I'm going all the way to, you don't need all this, but oh my goodness, right. So here's the one I meant. You could just hopefully skip to the slide. Looking at 2/5, so we're going to find our fifths. 1, 2, 3, 4, 5. There's our fifths. And if you think about it, it's coloured in 2 of them. And then we're going to look down to our tenths. So here's our tenths. And then we're going to see how many tenths are the same as 2/5. So there's our fifths. And there's our tenths. How many is it that's the same? So you can use that. It will be easier if you're doing it, and you could potentially do it yourself. I'd recommend that. Oh my goodness, I've got to go through all this again. That was so silly of me. And come on, there we go. So use the fraction charts to help you. And I'm not going to tell you any more about them. You can use your noggin to work them out. This one gets tricky. It's a bit of an open-ended one, that one. This one, I want you to write 3 equivalent fractions for each of these. So these are tricky now. So you've got to try and write 3 different equivalent fractions for these fractions here. So you do 8/16, and then I want to do 3 more fractions that are equivalent to that. You might want help drawing those out, possibly. It could blow your mind if you have to draw out all those equal parts, but I think you might be able to spot a pattern in that one. That one you should hopefully be able to work out, and that one's tricky and will blow your mind. Then finally, well, not quite finally, which is the odd one out? So here's some different representations. Which one's the odd one out? That's more just sort of modeling it, because the red challenge is you can make your own sets of odd one outs. So you could make one or you make more of fractions. So try and work out which is the odd one out there, and then you might be able to make up some of your own sets for an extension. Finally, here's an extra challenge. If all that has been so fantastic, you wanted more. All right, see you later.